Good afternoon, ladies and gentlemen. My name is Irina Holubova, and together with my colleagues Pavel Koupil and Sebastian Hrycko, we have proposed and implemented a tool called MMInfer, which is able to infer a schema for multimodal data. The context of multimodal data is much more complex than when we work only with relational or with graph data, because the combined models have contradictory features, and the resulting structures are much more complex. We have cross-model integrity constraints, we have intermodal references, etc. And what is worse, there are no standards how to combine multiple models. Our aim is to infer a schema for multimodal data. So to create a unifying description of the structure of the data, which can be then used for various purposes. Our two primary aims were to create or to propose an approach and implement an approach which can be applied universally and cover all specific of individual supported models. We support the 5 currently most popular models we can see down here. And our second aim was to be able to process also large amounts of data, because many multimodal databases are distributed and work with big data. On the right, you can see the architecture of MMInfer. The green part is the input. So it represents the selected multimodal database or a combination of single model databases where the multimodal data are stored. The yellow part is called local schema inferer, and it infers both so-called local schemas, and it also extracts various statistics from the data, which we call fingerprints, and which are then transformed to a set of candidates for various integrity constraints, references, redundancy, etc. Both these information are then combined in global schema infer, the red part, to the resulting multimodal schema, which is then transformed or represented in the selected format in the violet part. The main problem of MMInfer is how to grasp multimodal data, how to grasp all the specifics, all the features. So for this purpose, we propose a data representation or data structure called record schema description. As you can see on the right in the example, it's not very user-friendly and it's not expected to be read by written by the user. And it enables to describe a schema of one kind, of one record, of any of the five models we consider, as we can see here in the unifying table. And it is used for representation of the input data, for representation of the intermediate local schemas, and also for representation of the resulting multi-model schema. For the demonstration purposes, the current version of MMInfer supports 3 types of database systems: document database MongoDB, PostgreSQL, which is currently a multimodal system, and Neo4j, which is a graph database. The user can select the particular database system, and within the particular database system, also the particular database that should be added to the inference process. Next, MMInfer detects all the kinds in all the databases that were selected by the user and provides basic candidates for redundancy that can be confirmed or refuted by the user. Next, the user can choose which of the kinds in the databases should be involved in the inference process and a particular inference strategy. Here we can choose whether the schema is inherited from the database, because there is one, or we can use our multimodal universal strategy. In case of the document database, since there exists also existing verified single model approaches, we support some of them. In particular, we support the approach from Brazisi and from Sevilla, which enable to infer a single model schema for a JSON document. Now MMInfer creates or generates the local schemas for each kind in parallel, because we assume that the data on the input can be large. And at the same time, it gathers statistics, which we call footprints. And on the basis of the statistics, it generates candidates for additional structural information. Here we can see the candidates. So we can generate or MMinfer can generate references, local integrity constraints like keys, foreign keys, unique data types, and redundancy. So regarding references, we can, for instance, see here that property 2 from kind knows refers to kind person. In case of data types, for example, here for an ID, we can choose whether the inferred data type integer is acceptable, or we can choose a more general data type. In case of redundancy, we can, for example, see that there is a kind customer in database products, and there is a kind person in database social network, and these probably describe the same information. Or we can see here that the product also occurs as a part of a kind order. In general, we support two types of redundancy, either partial or full, depending on the current domains of the respective values, which are either equal or one is a subset of the other. When these candidates are confirmed, MMinfer can infer the resulting multimodal schema. It is represented as a graph. Each node of the graph is one of the kinds. We can see whether the kind occurs redundantly in multiple databases or not. We can look at the structure and data types and other information about the kind, and the edges of the graph represent the references. So we know that, for example, kind knows refers to kind person. We saw it in the previous step. In the last step, we can choose the particular format into which the resulting multimodal schema should be transformed. The last part of our demonstration is devoted to real-world data from the Internet Movie Database, which was transformed to a multimodal version combining the graph model, the relational model, and the document model. If you look at the generated candidates, for example, in case of references, we can see that the episode refers to title, or in case of redundancy, we can see, for example, that directors being the part of kind title are redundant to kind person. The resulting graph can be seen here. We can see kind title, person, episode, etc. For example, episodes refer to title, or rating refers to title. We can also see that kind person and kind title are redundantly stored in two different models. So that's all for the demonstration. Thank you for your attention.